got a question here on mass extinctions of species. I think it's question 4. If you look at the geological record, there are a number of clearly identified intervals where the geology, the fossil record, says that things were fairly stable. And there were breaks between those periods when something dramatic happened, an environmental effect which caused mass extinctions of species. There have been 2 hypotheses which have been advanced to explain these extinctions, and there's a concern that more will occur. But they, I think, ignore one rather important point, and that is that if we look at the next, I think the next slide shows a series of points on a graph, which is a graph of a number of breaks. If you look at the numbers, the lettering on the right-hand side of the curve, the end of Permian was 250 million years ago, and the other bold one, about 65 million years ago, end of Cretaceous. They are the 2 biggest mass extinctions. And they, if you look at the left-hand graph, left-hand wording, ages of extinction events, these are the extinctions, but the axis, the horizontal axis, ages of volcanic traps. Now, volcanic traps are the major basalt flows that have been found over several places, and you can see all of the dotted points along the curve. These massive eruptions of volcanic lava have occurred right where the extinctions occur on this graph. Now, the alternative interpretation which has been advanced is that there were major meteorite impacts or even asteroidal impacts on the Earth which caused the extinction. Not really very viable explanation, because we know that there have been massive impacts on the Earth and they don't coincide with extinction events. But these big eruptions of lava do, and there are, I think there are 13 have been identified. I don't know if they're all on this graph, but there are these 13 extinction events identified, and all of them are coincident with big eruptions of lava. Well, why do they happen? I think we can go to the next slide and see a reason for it. This is a cartoon of the way the mantle of the Earth is convecting, losing heat, it has to, and that we've got, you'll see 2, 3, established plume, new plume, extinct plume, hot spots, and so on. I want you to see that there are 2 kinds of process in progress here. One is convection of the mantle, which is causing the mantle to cool and produces, for example, mid-ocean ridge. The material is rising there and spreading, and you'll have another kind of convection, which is occurring right from the bottom of the mantle, immediately above the core. You can see the bottom of the figure there is the core. And cryptocontinents are areas at the bottom of the mantle which are sort of floating on the core. Now, where you've got crypto ocean, that is where the core is heating the mantle, and it produces hot material which rises up narrow plumes a new plume there, an established plume. Where it's rising, that means the material of the bottom of the mantle is being projected upwards by convection, essentially. It's rising quite fast, meters per year, up narrow tubes. By narrow, I mean 10 or 20 kilometers across. That's narrow on the scale of the Earth. Now, if you look at the one which I've called the new plume, you see it's got a big plume head. This is a new plume which has started and which is transporting material up into a big bubble. That bubble is going eventually to reach the surface. And when it does, there'll be a massive volume of lava waiting to erupt. When it does erupt, you have one of those big blood basalt flows. And when that happens, that's the cause of the mass extinction. So it's nothing to do with asteroidal impacts. It's a volcanic process. This is the process in a diagrammatic form. It says it occurs when there's a new plume breaks through. But of course, plumes also have to die. And where these cryptocontinents, as I've got the shaded patches at the bottom there of the mantle, where those move around like continental drift, where they go underneath a plume, they shut it off. They stop the flow. And it's the new plumes that replace them that are causing the mass extinction.
If you enjoyed this video or like connecting with great minds, like, share, subscribe, and don't forget to hit that notification bell so you don't miss our next one.